Hello. So for this section, we're going to do transformations using matrices. A vector could be represented by an ordered pair, and this notation could also be represented by a column matrix, x over y, with square brackets on the outside. Polygons could also be represented in matrix form. We simply place all of the coordinates of the vertices into one matrix, and this is called the vertex matrix. For example, here. 1, 2, 3, 4. There are 4 points there. And the square has its vertices in the following coordinates. If we want to create our vertex matrix, we plug each ordered pair into each column of a 4-column matrix. A square has its vertices on the following coordinates. If we want to create our vertex matrix, we plug each ordered pair into each column of the 4-column matrix. So 1, 1, negative 1, 1, negative 1, negative 1, and 1, negative 1. So this is the square. All right. If we want to translate the figure 3 to the right and 2 up, we simply add 3 to the x coordinates and 2 to each y coordinate. So x1 plus 3, y2 plus 3, y3 plus 3, and y4 plus 3. So 1 plus 3, that is 4. Negative 1 plus 3, that's 2. Negative 1 plus 3, that's 2. 1 plus 3, that's 4. Okay. And then the y values, y1 plus 2, y2 plus 2, y3 plus 2, and y4 plus 2. So 1, 1, negative 1, plus 2 each. So that's 3. 3. Negative 1 plus 2, that's positive 1, positive 1. So 4, 3. 1, 2, 3, 4, 1, 2, 3. Right? 2, 3. 2, 1, 2, 3. Oops. And then 2, 1, 2, 1. And then 4, 1, 4, 1. So it's this box. So the orange translated over to the light blue. On the other hand, if we want to dilate a figure or make it bigger or make it smaller, we simply multiply each x and y coordinate with the scale factor that we want to dilate with. So for example, in this case is 3. We multiply 3 to each one of these and the y's. So in the case of the 1, negative 1, negative 1, 1, and 1, 1, negative 1, negative 1, just multiplying 3 to each would give us 3 and 3 for the first point, negative 3 and 3 for the second point, and negative 3 and negative 3, and positive 3, negative 3 for the last point. Now, using matrix multiplication. For reflection and rotation, for each xy point that makes up the shape, we use matrix multiplication. When the transformation matrix is the identity matrix, the matrix equivalent to 1, then the xy values are not changed. Changing values a, b, c, or d will lead to transformations of the original shape. When we want to create a reflection image, we multiply the vertex matrix of our figure with what is called a reflection matrix. The most common reflection matrices are reflection about the x-axis. Notice that the change was on the y value. Then there's a reflection about the y-axis. The x value was negated. The reflection about the origin, 1x, 1y. The reflection about the y equals x. Now, y equals x, remember they are inverse of each other. So the x changes into y, the y changes into x. For a reflection about the y equals x line, notice how the x and the y values are switched up. Remember that the identity is 1, 0, 0, 1. And look at that. the x's and the y values switch. So let's look at an example here. It says here, reflect the segment AB about the y-axis and graph it on the coordinate plane. Remember that each one of these are 1 point. So -1, 2 is a point, and 3, -2 is also another point. That's A. And then 3, -2, that's B. Okay, here's A and B. Let's connect that. So that's segment AB. Here in pink, this is the transformation that is being applied to those 2 points. Before you multiply that, just analyzing those negation on the x or y value, it looks like x was negated and y was left by itself. So remember in our previous lesson where we had f of x equals to f of -x, this is an even function, a reflection about the y-axis. So let's multiply those two matrices. Okay, so the first element is 1, 1. So 1, 1. -1 times 1 is +1. +1 plus 0. So that's 1. Second is 0 plus 2. So that's 2. Right. This third element there, that's 1 and 2. So -3 plus 0. That's -3. And last, this is 2, 2. So 2 and 2. Oops. 3, 0. -2. So -2. Right, so 1, 2. 1, 2 is here. That's A prime. And -3, -2. -3, -2. That's B prime. This is the new point. There you go. For these other transformations, we will share some Delta Math videos with you. And you can access them through the activities that will be assigned. Alright, so if we want a rotation of a figure 90 degrees counterclockwise, so counterclockwise, we will multiply the vertex matrix with this. If you want to rotate a figure 180 degrees clockwise, we multiply the vertex matrix with this. Notice that it's -x, -y. For here, the x and y switch place, and the x value is negated. If we want to rotate a figure 270 counterclockwise, or rotate the figure 90 degrees clockwise, we multiply the vertex matrix with. So for this example, we want to rotate the vector 90 degrees clockwise, that's counterclockwise, clockwise, just like that. We will multiply this matrix with that. The transformation matrix has to go in front of the set of coordinates that you want to transform. So the transformation matrix goes first, then the matrix you want to apply it to. So it'll be 2 by 2. All right. -1, 0 plus -1. So this is -1. All right. This element, row 2, column 1. -1, +1. This is row 1, second column, 2 times 0 is 0, plus 3, and last, row 2, 2, and 2. 2 times -1 is -2 plus 0, so -2. There you go. So whereas the original is -1, -1, and 2, 3, this is the vector. This is A. vector A, so from here to there, negative 1, 1, and 3, comma 2. So starting from here all the way there, this is A prime. There you have it.